Being creative. I heard those words many times since I was in elementary school. I remember hearing about multiple artists who were considered creative geniuses, who were capable of great works that totally broke standards. But where does creativity come from? It's in an inborn or a learned skill. Some people suggest it's spontaneous. Meanwhile, others have the idea that in order to be creative, we need to have knowledge. However, the truth is all of us are involved in a world ruled by creativity. What's the first thing we think of someone talks about creativity? Exactly, art. Possibly, when we hear the word creativity, the first thing that comes to mind is that famous painter for making a painting, or that singer-songwriter who has just released a new single. That's what we commonly associate with creativity. Dalí's, Picasso's, Pavarotti's, any of them are creative in the eyes of society. But what would you think if I told you that an Einstein, Pasteur, or any scientist of today is a creative person? Creativity is a concept associated with the ability to create new things and to generate new ideas. In addition, it's very important to take into account that the result of creativity is something that has a purpose. So, we can consider that anyone who is capable of creating something new with value is creative. Creativity requires an effective use of mental capacities and abilities. Therefore, it's a faculty of the human being. So, if it's in an inherent quality of us as human beings, here's the main question. Why do we exclude science from this concept? The main reason we think there's no room for creativity in science is the method by which we become familiar with. I mean, the way we were taught. In the words of Bill Wallace, science teacher at Georgetown Day School in Washington, D.C., students think of science as a body of knowledge, a collection of facts that they must memorize. We came to think that science is nothing more than following a pre-written method and collecting a lot of information through a single path. You just have to go back a bit in time in our school days, in which during science classes we were shown terms one after another, or even mathematical formulas through a very mechanical and iterative method. At least, for my part, I have always enjoyed science, but what would you, a person think who is not so close to it? How do you explain to them that science can go further? In this approach, is not entirely wrong, since the basis of this creative process in science consists of the application of prior knowledge and, of course, the use of the well-known scientific method that has been the holy grail of scientific thought. However, where do we find originality if we only walk in one direction and ignore the infinite possibilities that we can imagine? Let's just visualize the following statement by Wallace about the teaching of science. What if we see science as a process of learning, observation, and information gathering to understand a phenomenon from multiple perspectives, which allow us to question ourselves and devise new ways of applying what we know to the problem we want to sort out? Creativity is conceived as a quality that can be developed, which is why many people in charge of teaching science in children and young people suggest activities such as science fairs or the implementation of problem solving with the possibility of solving them in 1,001 ways and be able to interpret a phenomenon they are analyzing. Another important factor in determining creativity in science is imagination. Scientists are people with great imaginative potential. Einstein said that imagination in science is more important than knowledge. For him, knowledge is limited, since we ourselves must be able to explore a situation through our imagination. Well, why should imagination be the starting point? Well, that can be explained under a term called creative imagination. In a general concept, creative imagination is what allows us to find what is innovative through divergent and convergent thinking, aspects that give the possibility of thinking about a great variety of ideas and selecting the correct one. Imagination is the ability of human beings to abstract beyond common sense. In this way, we can identify how events occur and the operation of different observed events. According to John Martin, professor of cardiovascular medicine at the University of London, he states that the ideas are the main component of any experiment, since they allow to establish its formation. According to him, an experiment without an idea has little value because ideas are universal and transcendental, while experiments are limited to the conditions that make it reproducible. In the same way, we must highlight the importance of imagination in the development of hypotheses, because these are not generated with a specific method, but with an idea that we believe is the solution to a problem. Of course, not all the ideas that come to mind can be an explanation of the phenomenon we are observing. It is necessary that the researcher be a scientifically cultured person. Paul Feyerabend mentioned that training an expert is not difficult. It only takes an average of 3 years of study. But training a scientist takes time, conditions, and creative audacity. But what does he mean by this? A simple answer. The person must not limit himself. He must know other developments in the field of science and appropriate several to establish a combination. Likewise, a scientific idea can be dominated by analogies and states of unconsciousness, in which we relate several ideas from multiple disciplines to apply them in the field to which one is dedicated. Possibly, if we limit this creative resource to just one discipline or to fill ourselves with simple data, we would not be able to prepare our brain to explain the phenomena that occur around us. Returning to Einstein, obviously at that time it was a totally revolutionary idea because popular belief considered that scientists operate under the first domain of human consciousness. This perception involves the skills of control, analysis, causality, and deduction. This is judged through logical and rationality. For this reason, science is established within this category, since to understand a phenomenon it's necessary to combine multiple factors and see their relationship between each other. However, this vision of a cold and calculating individual who is skeptical of any proposal or intervention of his emotions is an important problem when ignoring the figure of the scientist as an important part of the thought. The existence of the external world as a practically infinite collection of things, facts, and relationships is not an independent reality of us, but an interpretation that we make of what we perceive through our senses, our experience. Let's give an example. We meet two people who are examining an X-ray. One is a student and the other is his radiology teacher. Both manage to observe the different figures that are formed on the plate. However, the second is able to understand the various patterns and give them an interpretation. Therefore, reality is dependent on the observer and all the cognitive process that he performs. A little more than 400 years ago, science acquired a very relevant word in words. That is, any phenomenon was understood through oral or written language, something that some sectors consider appropriate today, which we can even continue to observe in textbooks or articles in some disciplines due to the multiple forms of learning that exist. Certainly, this is difficult for the understanding of models such as the atomic ones and the study of anatomy or the refraction of light, since they require a visual basis to determine the relationship between the elements. Therefore, science began to decipher these phenomena from images. The scientific thinking mechanism seems to have exchanged words for visual elements capable of making connections. Multiple highly recognized scientists, such as Niels Bohr, or we return to the case of Einstein, consider a creative vision in science is essential to refer to the ability of the scientist to apply his imagination and generate mental constructions regarding the different ways of functioning of the universe. In addition, they highlight that science not only describes facts, but is capable of creating images. To summarize all this, we can say that the scientist has a way to explore nature. First, imagining how it could be, inventing possible explanations of reality, designing theoretical models that seek to duplicate the structure and functions of more or less narrow segments of the nature, and then confronting their imaginations, inventions, and theoretical method with the reality itself. For all of the above, it's important to consider science as an essentially creative activity, which allows us to see reality through the eyes of the majesty of nature. Thank you.